Okay, this morning, excuse me, I'm going to show you a lot of different examples of solving single-step equations. So equations that take one single step in order to solve them. Okay? So start off with one that has addition in it. So we have x plus 7 equals 12. Okay? And we always want to start with, we want to subtract when we have addition. So we want to get rid of the 7, or we think about getting the x by itself. Okay? So we want our variable to be isolated on one side of the equal sign. Isolated means that it's by itself, okay, away from everything else. Okay? So to do that, we're going to get rid of this 7. Well, the additive inverse of 7 is negative 7. Okay, so we're going to add negative 7 or subtract 7, whichever one you want to think about. Okay, that will give us a 0. Okay, so we'll subtract 7 to this side, and then in order to keep our equation balanced, we want to also subtract 7 to the right side of the equal sign. And then sometimes we draw this line down here, or a solid line, just so that we know that that's where the equal sign is, so that we make sure we're adding or subtracting to both sides of the equation. And then we can go ahead and if you want, you can draw this line too and actually act like you're doing an addition problem. Find like terms. X, there's no like term with x, so x plus nothing is just x. Okay? 7 minus 7 is 0, so I'm going to put the 0 down. This is an extra step for some of you, but others it's a good step. Okay, 12 minus 7 is 5. And then you can just think x plus 0 is just x on the left-hand side equals 5. Okay? Okay, let's move on to a subtraction one. So when we added to a variable, we subtracted to get rid of that number, to get the x by itself on the last problem. So now when we subtract 4 from s, we're probably wanting to add to both sides. So we have s and negative 4 or minus 4 plus 4 is 0. So we just end up with, on this side, the sum total of this is just s. Okay? So I'm going to back up and get that circle off there. S equals, and then negative 9 plus 4 on the right side is negative 5. Okay? Quick little single steps to do this. Remember, whatever you do to one side of an equation, you have to do to the other side. Okay? Or you can think of it, if it's multiplication and division, you really want to think of it as whatever you do to one term, you have to do to all the terms. Okay? So that was subtraction. So when we subtract from a variable, we want to add to get rid of the number. Okay, now multiplication. Okay, the opposite operation of multiplication is division. So naturally, to get rid of a 4 that's multiplied by the q, we want to divide it by 4. So we're going to divide by 4 on both sides, or on every term. There's only 2 terms in this one. Okay, these 4s, we call it cancel. What they do is 4 divided by 4 is 1, and 1 times q is just q, so we can just kind of say that they cancel. Okay, so mathematically, they make a 1, and 1 times q is q, and then we just do 16 divided by 4, which is 4. Okay.
Oh, just check if it's open.
Okay, multiplication with a fraction. Now, okay, there's 2 ways to think about this. Since it is still multiplication, the opposite operation to do would be to divide. But this kind of looks really messy. Let's divide by 3/4, because we had 3/4 x. So the 3/4 is multiplied times the x. And the 3/4 is multiplied times the x. There's a lot less confusing way to do this. If you remember, when we divide by a fraction, you can actually just flip the fraction that's in the denominator over. Okay, it's multiplicative inverse or reciprocal, and we can multiply by that number. So let's go back. Instead of dividing by 3/4, let's multiply both sides by 4/3. I'll show you what happens then. Okay, this should simplify it. That looks a lot nicer than having a fraction divided by another fraction. Okay, and now we just look at this. We have 4 in the numerator, 4 in the denominator, so those cancel. We have a 3 in the numerator and a 3 in the denominator, so those cancel. So on the left-hand side, it leaves us with an x equals. And then on the right-hand side, we just multiply straight across. 4 times 2, so straight across, 2 times 4, whatever, is 8 over 5 times 3, which is 15. And then we need to check to see if we can reduce. 2 comes out of 8, but not out of 15. 4 comes out of 8, but not out of 15, and so on. So I believe that one is reduced. Okay. So flip the fraction over and multiply by its reciprocal. So you want to multiply both sides by its reciprocal. Okay. And then division. Okay. In this case, we have our variable divided by 12 is equal to 3. So the opposite operation of division is multiplication. So to get rid of this 12 in the denominator, we're going to multiply by a 12 that's in the numerator. What we're going to do is multiply by the number 12, but I'm going to write it as a fraction, because that should help us when we multiply. Over here, I don't need to write it as a fraction. I'll just write it as the number 12. Because we were talking about r over 12 being a fraction, it's kind of nice to write 12 as a fraction out here, because now we have 12 in the numerator over 12 in the denominator, and those cancel, leaving us with r over 1, and r divided by 1, anything divided by 1 is itself. So r is just equal to whatever we have on the right-hand side, which is 3 times 12, so 36. Okay? And those are your one-step equations and how to solve them.